Hello everybody, welcome to the June revision exam for June exam revision for grade 6 to 8. Hopefully you will find this useful for you. We've got a lot to cover and I'm really excited. So let's jump right into it. I'm obviously not going to list everything with you, but here is the plan. Okay, if you haven't heard about Sharpies, Sharpies is a maths teacher reward program where you can earn points for doing things like attending this webinar. And then once you have lots of points, you can exchange them for gifts from the Sharpies gift shop, for lack of better name. If you want to sign up, I will send this PowerPoint presentation to you on Monday. So you can just click on this link either to sign up. And then, of course, once you've signed up, you can tell your teacher friends about it and get them to sign up as well. And, of course, score points for that too. Then we've got, the list of all our favorite resources. Remember that you can download the simulator of the calculator that we're going to use today from this link. Remember, it's also free. And then, of course, all of our favorite worksheets, and then my own personal maths blog, which is coming out soon. So, keep an eye out for that as well. Then, of course, the calculator we're going to be using today is the W5 through 5 essay. It comes in red, blue, and white. The important buttons that you need to know about, obviously your mode button, because we'll be switching between a couple of modes today. And then, of course, backspace for deleting anything. And then, of course, your change button, which we'll use when we do fractions and decimals, and your equals button for finding the answer. Okay, and then the modes we're going to be using today are normal and table and drill. So the first thing that I want to show you, and this is particularly for the teachers, are there any students who are joining us today? If you're a student, don't you want to just raise your hand for me? Okay, so everybody's a teacher today. All right, I will pitch it more teachery then. That's fantastic. It makes it a little bit easier as well. All right, so first things first, when you want to convert your class marks and you want to convert them to something out of 100, so you want to calculate all the percentages for your class list, what you do is you press your fraction button. At the top, you put whatever you want to change your total to. So we want to change our total to something out of 100. And then at the bottom, you put the total that your test is out of. So let's say we set an exam, which is out of 80. Okay. Then we press our right arrow key, we say times, and then we write our first student's mark in. So the first student got 55 out of 80, and we say equals, and we get 68 and 3/4, or 68,75, using our change button. Now your next student's mark, all you're going to do is just type in their mark and press equals, and then it will give you the percentage over there. And then your next student gets 63 out of 80, so he gets 78,75%, and your next student got 46 and equals, so he got 57.5%, and so on and so forth. Okay, so it's a really nice shortcut. What's really nice about this is you can share this with other teachers. As long as you're using a sharp calculator, that constant function or constant calculation works the same. So if you have just a basic desk calculator, what you would do is say whatever your total you're going to divided by whatever your total you're coming from is, so the total that you started with, then press equals, then say times and the first mark and equals, and then same, just mark equals, mark equals, mark equals, and it will give you the same totals for you. Obviously without giving you the fraction first, because desktop only work in decimal answers. All right, now I'm going to harp on mental maths quite a bit today. So I just want to show you our very cool drill function. If you haven't seen it, it's very, very nice. So if you press 0 for math, you will see that you have an option of 25, 50, or 100 questions using your up and down arrow keys. And if we go from left to right, you can choose the type of questions that you are doing. Okay, so from grade 6 and upwards, you should be able to do a mixed bag of questions, and it's very good for them to be able to switch between the different calculations. Okay, If you start teaching factorizing or you want to find facts pairs of a number, then I would recommend doing just the times tables or just the division, sort of to get their brain into that mode as well. Now the calculator is going to ask you a question. You need to type in the answer, then you press equals. It will give you a tick and a new question. If you get the answer wrong, it's going to mark it wrong and then repeat the question over again for you. And it's very patient. It's going to keep asking until you get the question right. Now, if you're stuck and you don't know the answer, you can leave your answer space blank and press equals, and the calculator will show you what your answer should have been. Okay, obviously you won't get a mark for that. So you have to answer it correctly the first time in order to get a mark for that calculation. Okay, so I'm just going to answer another 2 or 3 so I don't look so bad, and then I'm just skipping. So you'll see I won't get any marks for these because I skipped through them. And then right at the end is our mark, which we got 4 out of 25 or 16% for this drill function. Okay, so that's that one. So let's talk through some common errors and misconceptions. Now, obviously, the first thing that is very important is that students need to read the questions very carefully. Okay, and they need to be reading other things too. I know as maths teachers, we don't think it's important to encourage reading, but it really is actually very, very good for them. And in fact, there is research that shows that students who have good reading skills do better in mathematics as well. Okay, and it's all to do with stumbling over language and all of that sort of stuff. It activates the same center in your brain. So just do encourage reading. Reading is very, very good. And if we think about it for math lit students as well, they need to be reading what's going on in the world around them as well, so that they can form an opinion and that they understand where the questions from the exam papers are coming from as well. Then, of course, make sure that they write down the question correctly, write down the correct question number, especially when they're rushing through the paper, which is my next point. They often mix up the numbers. So the next thing to do is to teach them how many minutes it will take per mark to answer a particular question. So what I used to do with my extra math students is say, okay, today we're going to do a practice exam paper. The exam counts out of 80 and you have an hour and a half to do it. So basically you have 90 minutes and you have 80 marks. So that works out to a minute per mark, plus you have an extra 10 as a buffer. So if you have a question that is 3 marks, you can spend 3 minutes doing that question, if that makes sense. Okay. And then let them do that question for 3 minutes. Because often what will happen is they'll realize how long 3 minutes actually is. And they'll be able to work slowly and consistently through the paper. So instead of rushing to finish the paper and, having all this time at the end and then not going back to check, they can instead work slowly through the paper and not make silly mistakes because they've been rushing. Make sure that you write down, and this is for the students, write down all of your steps, okay? Show all of your working out, because if you make a mistake in an invisible step, in other words, you make a mistake where you haven't written down the step, we cannot follow through with your logic, so we cannot give you the marks for that, okay? And then particularly for integers, pay attention to your signs, check them twice, and remember your rules. Okay, and if in doubt, from grade 6 and up, according to the CAPS documents, you are allowed to check your answers with the calculator. So obviously, not necessarily in exams will you be allowed to use the calculator. That's up to the school. But yeah, check your calculations, especially when you're practicing on the calculator, and make sure that you're getting it right. And then, of course, never, ever, 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 ever try and divide by 0. Then when you're working with measurement, which is more of a term 3 topic, make sure that your units are all the same. That's one of the ways that they will catch you out in the question paper. And of course, BODMAS is a thing and it exists until the end of matric. Okay, so pay attention to your BODMAS rules. Remember, when we get to grade 8, we don't use O as of, we use O as other. So other stands for things like exponents, squares, cubes, roots, etc., etc. Okay. All right. So let's talk about long division. So the first thing to do is to remember your rhymes. So I just wrote DMSB, and basically the rhyme that I know means daddy, mommy, sister, brother. Okay, so daddy for divide, mommy multiply, sister subtract, brother bring down. Okay, and then remember to practice your mental maths, because long division is all about knowing what goes into what, how many times. So if your mental maths is really strong, then this becomes much easier. Okay, and the thing with mental maths is the stronger your mental maths is, the less mental load you are applying to the mental maths part, and the more you're applying to the actual question. So the better your mental maths mark, or the better your mental maths is, the easier you are going to find these questions. Now, there is research that shows that students who are strong in mental maths when they are in primary school get better matric results later. So another good reason to keep practicing your mental maths. And mental maths is great. I mean, you can do it anywhere. So whether you are driving in the car with your mom and she's practicing times tables with you, or whether you're doing the drill function on the calculator, or whether you use flashcards, or whether you stick post-it notes up all over the house with the different answers on different questions, or whatever you do, practice your mental maths. Okay, so with long division, it means showing all of your steps. Okay, so short division means we write the long division steps down really small, and we leave some of the steps out. So you need to be able to do long division first before you ever progress to short division. Okay, so, sorry, I wrote that a little close and that's not going to make it easy. Okay, so here we've got 896 divided by 7. And I just want to go through this rhyme with you and show you how it works. So daddy divide means we say 7 goes into the first number, which we can do. 7 goes into 8 once. So we write down 1, then we say mommy multiply. So 1 times 7 is 7. Then we say sister subtract. So we say 8 minus 7 is 1. And then we say brother bring down the next number. Okay. Then we say, okay, 7 goes into 19 twice. That's daddy divide. Mommy multiplies this. 2 times 7 is 14. Then sister subtract. So 19 minus 4, well, 9 minus 4 is 5. 1 minus 1 is nothing. And then brother bring down the 6. 7 goes into 56 8 times. Okay, and I know that because I know my times tables. 8 times 7 is 56, so that's mommy multiply. Sister subtract, so that's a 0, and that's 0, and there's nothing left to bring down, so we are all done, and our answer is 128. Okay, all good? Awesome. All right. Then the next step in our journey is multiples and factors. So multiples are the things that we're counting in a specific value. So we're counting in 5s. So 5, 10, 15, 20 are all multiples of 5. Okay, they're the answer to multiplication sum. Factors are the numbers that divide perfectly into that other number without any remainders. So again, learn your times tables, do your mental maths, practice them because they're going to help you with this. And remember, you use multiples and factors, not just in the section called multiples and factors, but you use them in finding your highest common factor, and then we use that theory and knowledge to find our lowest common denominators when we're using fractions, and then when we are doing things like trinomial factorizing in grade 9, it's still coming, don't panic. All of those things are based on the fact that you know multiples and factors. Okay, so I wanted to show you a really nice way if you're struggling to find the multiples of something. So let's say we're going to find the multiples of 13. Okay, so on your calculator, we're just going to choose 2 from mode, and then we're going to find the multiples of 13 by typing in 13, pressing our RCL button twice and saying equals, and then equals, 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 and here are all of our multiples. So we've got 13, 26, 39, 52, 65, 78, and so on. Now, this is really helpful when you do division, long division and short division, because then you can find the various multiples that you need in order to answer that question. Now, we can also use the calculator to find factor pairs. So if we wanted the factor pairs, say, of 36, then we can say 36, then we press our fraction button, we press RCL twice, and equals, equals, equals. Anything divided by 0 is undefined, which is where that little line comes from. Okay, so just remember that stripy line means undefined. Then we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So we know 5 is not a factor because it has a decimal answer, it has a remainder. So we ignore 5 as a factor. Then we have 6 and 6, which are factors. And then, of course, we've got 7 and 5, 1 and 4, blah, 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 blah. So we know that 7 is not a factor. And in fact, we've crossed over and are now repeating the factors. So we've got all of the factors that we need. What's really nice is your table is unlimited. So you can really go and look that you have actually got all of the factors if you needed to as well. Okay. Awesome. So that's that. Right. So prime factors are basically factors that are prime numbers, right? So a prime number is a number that only has two factors. Do you see how all of this theory comes together? So basically, you can't divide it by anything other than itself and 1. Okay. 1 is not a prime number. It's a special number. So it doesn't count as either prime or composite or any of those things. It's just 1 by itself. It's got amazing properties, the number 1. Okay. And then, of course, we can use the ladder and the branch methods to help us find prime factors. So I'm just going to do these two examples with you. So here we've got 72. And what we do is we just go through our list of prime numbers. So we'll start at 2. Now, 72 is even, so we know that 2 goes into it. So 72 divided by 2 is 36, right? Then we can see 36 is even, so we're going to divide it by 2 again. That gives us 18. And we can see 18 is even, so we're going to divide it by 2 again, and that gives us 9. Now, 9 is not even, so we can't divide it by 2. So we think about our next prime number, which is 3. Now, 3 does go into 9 3 times, and 3 goes into 3 once. So our prime factors are 2 times 2 times 2 times 3 times 3, or 2 to the power of 3 times 3 to the power of 2. Then if we want to use the branch method, okay, what we would do is just write down our number and we split it up into branches. So 84 we know is even, so I'm just going to do the easiest version, which is to split it up into 2 times something. Now 8 divided by 2 is 4, and 4 divided by 2 is 2. Now 42 we can split into 6 times 7, right? So we know 7 cannot be split because it is a prime number. So we can split 6, which is 2 times 3. Now both of these are prime numbers, so we have finished, and all of the apples on your tree are your prime factors. So it's going to be 2 times 2 times 3 times 7, or 2 to the power of 2 times 3 times 7. Okay. All right. Now, of course, there is a lovely shortcut on the calculator to find your prime factors. So we can press home, and then let's say we wanted the prime factors of 84. We would say 84 equals, and then second function, and this button here in orange, you can see it says pfact. So there you go. And that's exactly the same answer that we found. So we know that our method is correct. So we can check our answers again using this knowledge. Now, this becomes useful when they get to grade 9 and they start looking at exponential equations and solving those. All right. So from here, we look at the highest common factor and lowest common multiple. So the highest common factor is the largest factor that goes into a set of different numbers, so 2 or more numbers. Then your lowest common multiple is the lowest number that is the same multiple for 2 or more numbers. okay? And we can use prime factors to help us find it. So what I'm going to do here is I'm going to say the highest common factor of 14 and 21. So I'm going to say 14 is equal to 7 times 2, and 21 is equal to 7 times 3. Okay, now we can see that factors-wise, the highest common factor, or the factor that is common to both 14 and 21, is 7. So our highest common factor is 7. Now we can do the lowest common multiple in 2 ways. Okay, so we can say, all right, 14, then the next one is going to be 28, then the next one is going to be 42, and then the next one is going to be 56, right? 21, we've got 21, then 42, then 63, and we can see that we have 42 in our count of multiples. So then we can see that our lowest common multiple is 42. Now it's easier to do with numbers like this, but when they're not so obvious, there is another method. So what you can do is you can complete a table like this. Okay. So you have 14, and the factors of 14 are 7 and 2, right? And then we have 21, and the factors of 21 are 7 and 3. And then what you would do is just multiply the columns together. So we have 7 times 2 times 3 to give us our lowest common multiple. So 3 times 2 is 6, times 7 is 42. So our lowest common multiple is exactly the same. Now there is again a nice shortcut that has been added to the Sharp calculator. So if we want the highest common factor of 14 and 21, we can say 14, second function and 2, and then 21 and equals, and it gives us 7, exactly what we were thinking. Then we can say 14, second function and 3 for LCM, and 21 equals, and we get 42. Just a side note, GCD stands for greatest common divisor. It means exactly the same thing as highest common factor. So it's just a different way of putting it. All right, fantastic. Now, for exponents, remember that x times x times x is x to the power of 3, but x plus x is 3x's, okay? So in other words, this is a dimensionality question over here. One side times another side times another side, it's 3D, whereas 1 apple plus 1 apple plus 1 apple gives me 3 apples, or 3 lengths together. Okay, and then remember that the law applies to the entire bracket. So I always used to tell the kids at Exponents that this is a germ and it affects the whole room. Okay, it doesn't just affect one person in the room, it affects the entire room. Okay, so make sure that they apply the exponent to the entire bracket. And then, of course, remember your laws and the fact that anything to the power of 0, regardless of what that anything is 1. Then what I've done is I've just done the buttons for you on your calculator so you can see how they work. So these are the buttons that you would need to use. And then for students, it's a very good idea to memorize the squares between 1 and 12 and your cubes between 1 and 5. Okay, this will just help to speed things up when you're doing calculations. Now, for scientific notation, you can actually just do it on the calculator because it's a grade 8 thing. So they should have a scientific calculator at this stage. Okay, so if we have 3.4 times, and we can do it just standard as typing in the 10, putting in an exponent, and then typing in the power of the exponent, which is 5, times 7.9, or we can use a second function and log, and you'll see it just gives us that 10 to the x. You'll see the 10 is written differently. Means the same thing. So there we go. So it's just 2 different ways to write it, and equals, and then you can see we get 2.86, and e means times 10 to the power of 12. It's just the old way of writing it. All right. Then we can also set up our calculator to use scientific notation. So we can say press setup, Then we're going to press 1 for FSE. We can choose 1 for scientific. And then all it's asking for is how many digits would you like? So let's say we want 3 significant digits. Then you can see it's 2,69. So it's actually just rounded it off for us to 3 digits in total. Okay. If you want to return back to the normal way of doing things, so you don't want scientific notation on your calculator all the time, then just press 1 for FSE and you choose 3 for norm 1. And then it goes back to how it was before. Okay. Any questions so far? We all good? All right, fantastic. Okay. So with fractions, when you add or subtract the fractions, you need to make sure that your denominator is exactly the same. Okay, so we cannot add these without first changing the denominators to be exactly the same. And that's why we need to know how to find our lowest common multiple. Okay, so here we can see that, or let's just check it quickly on the calculator. We've got 3 and 6 and 24. So our lowest, oh, sorry, I said GCD, that was a mistake. Lowest common multiple, there we go. 24. My goodness me, there we go. So the answer is 24. So in fact, our denominator is going to be 24. All right. So we're going to have 24 and something over 24. And the last one we know is 5 out of 24. Okay. Now, how did we get from 3 to 24? We multiplied by 8. And the golden rule says what you do to the bottom, you do to the top. So 1 times 8 is 8. How did we get from 6 to 24? We multiplied by 4. What we do to the bottom, we do to the top. So 1 times 6 is 4. There we go. And then we can just add them all up together because now our denominators are the same. So 8 plus 4 gives me 12, plus 5 gives me 17, and my denominator stays the same. Okay, because it's just parts out of something. So remember, when you're adding, your denominators don't change. Well, they change so that they are exactly the same, but you don't add the denominators together and you don't subtract the denominators. Okay, the denominators tell you how many parts of something you have. Okay. When you multiply, first factorize first find the factors in your fractions. It will make it much, much easier. And remember, when you are dividing a fraction, you can tip the fraction over and multiply it. So let's go and do those examples. So here what I mean is, okay, 11 is a prime number, so we can't break that down. But 12 we can break down into 2 times 6, right? Okay, and then we have 14, which we can break down into 2 times 7. And 66 is 6 times 11. Okay, now what we do is we go and we look for 1 in the top and 1 in the bottom. So I've got an 11 in the top and an 11 in the bottom. And basically what it means is 11 divided by 11 is 1. Okay, so that's 1. And then I've got a 2 at the bottom and a 2 at the top. So a 2 divided by 2 is a 1. And then I've got nothing else that matches. So I'm going to move on to my next step. 1 times 1 times 7 is 7. 1 times 6 is 6, times 6 is 36, times 1 is 36. So my answer is 36. Here we've got 88 divided by 15. 88 over 15 divided by 1/8. So we first tip in times. And we've got 8 times 1. Now, 15 is 5 times 3, and 88 is 8 times 11, and 8 is even. So none of those factors match each other, and we just have to multiply. So we can do it very quickly. 88 times 8. 8 times 8 is 64. 8 times 8 is 64, plus 6 is 70. So we have 704 over 15 times 1 is 15. Okay. Cool. Then for decimals, decimals are fractions that have denominators that are 10, 100, or 1,000, and so on. Okay, so the number of zeros tells us how many decimal places we have. Okay, so if I have 1 out of 10, I have 1 decimal place and the 1 slots into it. When I have 1 out of 100, I have 2 decimal places. So I start from the back, I fill in the 1, then I fill in a 0 as a placeholder because it cannot just be left blank, sorry. And then I've got a comma 0. Okay, when you want to convert a fraction to a decimal, you first need to convert your denominators to something out of 10, 100, or 1,000. Okay, and then of course remember to use your zeros as placeholders like we did over here. So 2, we know, can convert to something out of 10. We can multiply it by 5. And the golden rule says, what I do to the bottom, I do to the top. So 1 times 5 is 5. Okay, then here we've got 1 decimal place. So I have a comma and a space for 1. My 5 slots in there, and I put my 0 in front of the comma. For these ones, we have 1 out of 4. Now 4 doesn't go into 10 perfectly, it goes into 100. So how many times is 4 in 100? It's 25 times. What I do to the bottom, I do to the top. So 1 times 25 is 25. Okay, then again I have 2 placeholders for my 2 zeros and a comma and a 0 because I have no whole number. And then I fill in from the back. So I've got a 5 and a 2. I have no empty slots. So I'm all done. And then what I've done on the calculator is just checked it for you. So all I did is type in the fraction, pressed equals, and then press change to give me my decimal. Okay, here we've got 1/8. Now 1/8 doesn't go into 100 perfectly, but it does go into 1,000 perfectly. And I know this from long years of practice. Okay, so just a heads up, learn these ones because they are pretty common and they'll always show up. Okay, now how did I get from 8 to 1,000? I multiplied by 125, right? And what I do to the bottom, I do to the top. So 1 times 125 is 125. Now I have 3 zeros, so I have 3 placeholders and a comma and a 0 in front because there's no whole number. Then I write it in from the back. There's no empty slots, so I'm all done. And we can check on the calculator. Yes, I'm correct. It's all good. Okay. Now, these ones are not, it's not possible to get from 7 to 10 to 100 to 1,000. So what we have to do is actually use our long division skills. And we're going to just add some zeros behind it. Okay, so this will depend very much on how many decimal places they ask you to find. Okay, so 7 goes into 3. We can't do it, so we write down a 0. We bring up our comma, okay, and then we group the 2 together. Now 7 goes into 30 4 times, so we write down a 4. Then we remember our rhyme: daddy, mommy, sister, brother. I always write them down just because it's much easier to follow a rule when you can see the rule. Okay, so 4 times 7 is 28. And of course, I'm going to bring down the comma as well. Then we say sister subtract. So borrow from there. 10 minus 8 is 2. 2 minus 2 is 0. Brother, bring down the 0. 7 goes into 20 twice. Mommy multiply says 2 times 7 is 14. Sister subtract. Borrow 6, nothing. Bring down a 0. 7 goes into 60 8 times. 8 times 7 is 56. Sister subtract. 10 minus 6 is 4. 5 minus 5 is 0. Bring down a 0. And you can see that this is endless. Even from the answer on the calculator, you can see the pattern starts to repeat itself only later. Okay, so we can just say dot, dot, dot. or we can round it off depending on what the question actually requires from the students. Okay, then for this one, we've got 52 divided by 9, and this is a special one because it is a recurring number. Sorry, I don't know why my mouse jumped over there. So again, you put in your zeros. We say 9 goes into 52 5 times, right? 5 times 9 is 45. Sister subtract. 12 minus 5 is 7. And 4 minus 4 is 0. Bring down a 0 and a comma. So we're going to put a comma up there. 9 goes into 70 7 times. 7 times 9 is 63. Sister subtract. Borrow. 10 minus 3 is 7. 6 minus 6 is 0. Bring down a 0. We've got 70 again. So you can see the pattern is now repeating itself. And we can just do the same thing over again. And you'll see that the pattern continues on endlessly. And that is a recurring number. So we can write a little dot on top of the 7 to show that it is recurring because the pattern just keeps repeating itself. Now, on your calculator, you actually have a recurring number function. Okay, so to set it up, we press setup and we choose 5 for recurring decimal, and then we just say 1 for on. Now, if we said 52 divided by 9, like we were doing there is our mixed number fraction. And if we change it, there is our recurring decimal. So you can see it's got the little line on top to say this number is repeating endlessly. And then, of course, your numbers that your actual recurring number. Now, the calculator will always round it off, but we know that the 7s are infinitely long. Okay. So there's the instructions for you. Okay, percentages. So a percentage is a share or a fraction of 100 parts. And the percentage sign comes from the 100. There's your 1, there's your 2 zeros. Okay, then to convert from a percentage to a decimal, we divide by 100. And to go in the opposite direction, so from a decimal to a percentage, we simply multiply by 100. To convert from a percentage to a fraction, first we need to write the percentage over 100 and then simplify that fraction. And then to convert from a fraction to a percentage, we find the equivalent fraction where the denominator is 100. And then we simply write it down. Sorry, I need to remove that line. I'll change it before I send this to you. So let's do some examples. What is 50% as a decimal? So the first thing is we need to divide it by 100. So we have 50 over 100. And then we know we have 2 spaces, so space and space, comma and a 0 in front. And then we fill in from the back, 0 and 5. So in fact, we could write it as just comma 5 and drop the 0 because it's unnecessary. If the 0 is the last thing in the line, we don't have to write it down. But when the 0 is in front of a digit or a number between 1 and 9, then it has to stay there. Okay, you can't drop them when it looks like this, just to be clear. That 0 is a placeholder. It's telling you that there are no tenths there, but there are hundreds. Okay, if you dropped it, you would make it 5/10. So you would change the value of the answer. Okay. What is 0.75 as a percentage? Well, we simply multiply it by 100. When we multiply by 100, we shift these two over to the left. So in other words, our decimal is shifted to the right. Okay, so 75 times 100, we have 2 zeros, so we shift twice over and we have 75%. Yes, so Anna's mentioned something important. If the answer must be correct 2 decimal places, then you must include your 0 at the back. So pay attention to how the question is asked. But for grade 6s, I don't think it's, no, they don't even do decimals in grade 6. So for grade 7s, yeah, they don't necessarily have to put the 0 in, but I think from grade 8, they do need to be able to have to 2 decimal places and so on and so forth. Alrighty, then here's some more examples. So write 80% as a fraction. So we know that we are going to divide 80 by 100, and then we are going to simplify it. Now, the easiest thing that we can see is multiples of 10. So we can divide both by 10. So we're going to have 8 over 10. And then again, we can divide by 2. So we have 8 divided by 2 is 4. And 10 divided by 2 is 5. Okay. Then this example here, write 7/8 as a percentage. Okay, so we know that 8 doesn't go into 100, it goes into 1,000. Okay, so we're going to do that. So we're going to have 7 over 8, and we're going to convert it to something over 1,000. And I'll come back to it in a minute. Okay, so we know 8 times 125 will give me 1,000. So we have to say 7 times 125. So 7 times 5 is 35. Carry the 3. 7 times 2 is 14. Plus 3 is 17. Carry the write down the 7. Carry the 1. 7 times 1 is 7. Plus 1 is 8. So there it is. There. Oh, sorry. Okay. Now, once we have that, we can see that to get from 1,000 to 100, we just divide it by 10. Now, here we've got 875. So all we're going to do is shift the comma one place to the left when we divide. So we're going to put it here. So it's going to be 87.5%. Okay. Oh, sorry. I don't know why it didn't clear. Okay, integers. So remember your rules. When you multiply same signs or divide by same signs, then your answer is always a plus. So whether you say plus times a plus or minus times a minus or minus divided by minus, your answer will always be a plus. When you multiply different signs together, your answer will always be a minus. So minus times a plus is a minus, plus divided by a minus is a minus, and so on. Again, you need to practice your mental maths. Okay, then use the negative button on your calculator to make your answers negative and not the minus sign. That will give you an error. Okay, then for the teachers, here's a worksheet for grade 8. It's revision on grade 7 work, so you can use it for both grades 8 and 7 students. Okay, and then of course, don't rush. Pay attention to your signs. Look at what they're asking you. So I'm just going to do the first example here. So we've got minus times a minus, which is a plus. So we're going to have 5 plus 5. The minus is on the outside of the brackets and there's nothing inside. So we're just going to write down minus. And 2 to the power of 3 is 8. Then we're just going to follow it step by step from left to right. So 5 plus 5 is 10 minus 8. And 10 minus 8 is 2. And we are done. Okay. Now, number patterns, there are 2 different types. So the first is your numeric patterns, and these have to do with numbers. So you can add or subtract the same thing, or multiply or divide by the same thing over and over and over. Okay. Or you can have a pattern that has a special relationship with its position. So for example, you could have a pattern that is 1, 4, 9, 16, 25, and that is the position of the pattern squared to give us the pattern. Okay. Here, this pattern is the Fibonacci sequence, and how it works is you take the first term and you add it to the second term and you get the third term. Then you add the second and the third one together to get the fourth one. Then you add the third and the fourth one to get the fifth one, and so on and so forth. So this is a very different one. We call it a recursive pattern because it relies on our previous answers. Don't worry, you don't need to learn the word recursive until much later. Okay. Then, of course, geometric patterns are basically patterns that use pictures, but they follow the same rule. They're still adding or subtracting or multiplying and dividing by a different number. Okay, so here we can see I've got 1 leaf, then I've got 4 leaves, then I've got 7 leaves. So what have I done? I've added 3 each time. So my next picture is going to have 10 leaves. Still a numeric pattern, it's just shown in figurative form. Here we've got 1 little tiny Lego block, then the Lego block has doubled to 2, then it's doubled again to 4, then it's doubled again to 8. So we can see that we are multiplying by 2 each time. Now, number sentences are just a mathematical way of telling a story. So basically, you need to write down the story using numbers. Okay, so I like this version. So this is just an example. The link will take you there and work through the whole number sentences thing, but it's not complicated. Okay, so pay attention to the position of the words and how the words are said, and then make sure you read the entire story or the question before you start writing down important information. So here, if we see the sum means plus of 5 and 7 is 12. So we know we're going to add 5 and 7 and we're going to get to 12. So we can write it as 5 plus 7 is equal to 12. The quotient is the answer to a division sum. Okay, so the answer of 48 divided by 8 is 6. So we can write 48 divided by 8 is 6. And that's basically what number sentences are. Okay, I'm not going to do these examples because they're exactly the same. Now, functions are relationships between or a rule between an input value and an output value. And we can write functions in different ways. We can write them in tables. We can write them in flow diagrams. We can write them as a number sentence where you use a block for the missing piece. You can write them in words, like we did with these examples here. Or we can write them as a formula. Okay. You can also put your formula into the table on your calculator. So we can have 10x plus 2. Okay, so we're adding 10 each time and we're starting at 2. Okay, so we're going to have 12, 22. You can see we're adding 10 each time. And so this here is a table with your term position and the answer that you get, or your term inputs and the answer that you get when you use that input. Okay. So with algebraic expressions, a constant is a number. It stays the same. It doesn't change ever. Okay, so a constant is a number like 12. A variable is a letter. Okay, so it can change because you can substitute any other number into that letter. Okay. A coefficient is the number that's attached to a variable. Okay, and then the degree is the highest value or the highest exponent in your expression. Okay, so the degree of this expression is 5 because that is the highest exponent that we have. And then, of course, you can only add like terms together. Remember, like terms are terms where the variable and the exponent is the same. So your coefficients can be different, but your variables and your exponents must be exactly identical before you can add them together. Okay, any questions so far? This is the last section. So we're all flying along wonderfully well here. Okay, fantastic. So remember your theory. I've just written it down here for you guys, but learn it off by heart because it will help you with conversions. And then I just want to show you a quick way to convert minutes to hours. So go back home to normal mode. Let's say, for example, you have 470 minutes and you want to know how many hours that is. Okay, so we're going to say 0, and then we're going to press the DMS button, and we're going to type in 470 minutes. Now, the 0 is just a placeholder for hours. Okay, we say equals, and what the calculator does is it just calculates how many hours in those 470 minutes for you. So it's 7 hours and 50 minutes. And what we can do is say second function and DMS, and then it will change it into a normal fractional notation. So in other words, 7 and 5/6 of an hour. Now, the other type of question that you get is the Susie train station question. So Susie gets on the train at 9:45. She gets off at 12:30. How long was she on the train for? So we can say the later time first, so 12 hours and 30 minutes for 12:30, minus 9 hours and 45 minutes for 9:45, and equals, and it gives us 2 hours and 45 minutes and 0 seconds. Now, guys, you can add seconds to this question. by adding another degree sign, a DMS sign, and then say we have 50 seconds, for example, then that will give us that answer as well. Now, I just want to go back here. So you can again change your answer so that it's just 2 hours notation, so 2 and 3/4 of an hour. All right, fantastic. So this is a very quick summary. You can watch the other Term 1 and Term 2 webinars, which go much more in depth into the various topics that I've done very briefly here today. Okay, so this is the link to the channel. Then, of course, remember to practice. Email me if you need worksheets or you have specific questions. We have grade 8 worksheets and up. But I sometimes have worksheets for lower grades. I just have to go and find them. Or I can point you in the right direction for worksheets for the lower grades. Okay. Then remember, you cannot study maths the way you do other subjects. Yes, you have to know your theory. That's important. But you also have to understand your theory and then you have to apply it. Okay. So yes, it doesn't feel like you can study maths by sitting and writing out notes. That's not going to work. Yes, you must write down the theory of your notes, but then you must take that theory and you must go and practice it using examples and worksheets. And then what you do is you do 3 or 4 questions on the same topic. You go back and you check your answers. If you get them wrong, go back through your working and make sure that you can find where your mistake is. This is the most effective way to learn. In fact, students who study this way outperform students who don't. Okay. Then, of course, guys, ask questions. Your teachers love to answer questions. They'd rather you come and ask the question if you don't understand something. So if you are going through your maths, you should start studying your maths now if your exam is in 3 weeks' time. Okay, and you do a little bit every day, half an hour, 45 minutes. So do a little bit of theory, practice. If you don't understand or you're getting something wrong all the time, then go back to your teacher the next day and say, ma'am, I was trying this out, or sir, I was trying this out. What am I doing wrong? And they'll be happy to help you. Teachers love to see you doing extra work when you haven't been asked to do that. It makes them all glowy and happy inside. Okay, then of course, this website here, this link, how can I help my child study for maths? It was written by a teacher who's also a mom. So she's written it from the mom perspective, but with teacher insight. So go and take a look at that. It's a very helpful article on studying for maths particularly. All right, guys, thank you so much for your time. I hope that you have found this presentation useful and helpful. And yeah, remember that you can download the worksheets and the simulator from Maths.